Okay, so this is problem 3 from the third worksheet, which is exponential population models dealing with logarithms and summations or geometric sums. And in this problem, the thing that we want to notice is we don't know how many terms this is. So we need to figure out the subscript of that last term, 4,782,969. So for us to figure out what term that is, we have to write the explicit model P sub n equals P0 times R to the nth. Well, we already know the P0. And to find the R value, we said that R is equal to the next term divided by the previous term. So R is equal to 1/9 divided by 1 over 27. And R is equal to 1/9. When you divide by a fraction, it is the same as multiplying by its reciprocal. So R is 3. Now that we've figured out what R is and we know what P0 is, we can say that our model P sub n is 1 over 27 times 3 to the n. And this is the explicit function. So we want to figure out what number term this is. So we're going to replace Pn with 4,782,969 and set it equal to 1 over 27 times 3 to the n. So we want to isolate the 3 to the n. And to do that, we're going to need to multiply both sides by the reciprocal of 1 over 27. And when we multiply by the reciprocal, on the right-hand side, that becomes 1. And on the left-hand side, we're going to have to plug that into our calculator. So we have 27 times 4,782,969. So now we have 129,140,163 equal to 3 to the n. And as we've shown in a previous video, to get the exponent n isolated, to get it out of the exponent, we need to use logarithms. So the log has to match the base in the exponential expression. So log base 3 of 129,140,163 is equal to log base 3 of 3 to the n. The logarithm is going to cancel with the exponential base and extract the variable. So the right-hand side is now n. And the left-hand side, we have to use the change of base formula to evaluate it. So we go back to our calculator. ln of 129,140,163. Divide that by ln of 3. Hit enter, and it tells us n is 17. So that means that this term up here, the 4,782,969, is the term with a subscript of 17. That is P17. Well, if we're going from P0 to P17, that means we have a total of 18 terms. So let's clear this screen so that we can now do the next part of this problem. So the geometric sum is P0 times R to the n minus 1 over R minus 1. And in this sum, n is equal to the number of terms. In this sum formula, that n is the number of terms that we're adding up. So that n is going to be 18. So our sum is P0 is 1 over 27 times our R value is 3. The number of terms is 18 minus 1 over 3 minus 1. And now we can go back to our calculator. So 1 over 27 times 3 to the 18th power. Get out of the exponent, then minus 1, close the parenthesis, then divide by 3 minus 1 is 2, so we're going to divide by 2, hit enter, and our sum is 7,174,453.48. So that's the problem. First step, find the subscript of the last term. Second step, identify the number of terms, plug in your P0 and number of terms into the sum formula, and you get your sum. To find the subscript, we needed logarithms, and this problem had a little bit of everything in it.